Okay, so now we get to the big question that we've been leading towards. Can we factor something fully? So what we were talking in the last one is that if we can factor this fully, well, the first ones are going to have to multiply to give me 3x cubed. My last ones are going to have to multiply to give me 2, and there will be all this in between. But the key thing for figuring out what's going to be a factor is this last term. In our notes, they call this the factor property. So if we go right before example 3, they have the factor property here in our notes that says if something's going to be a factor of our polynomial, right, then that last value of that factor has to also be a factor of our constant term. So what does that mean? Well, when we look at our example, we're looking at this number, 2. What are the factors of 2? 1 and 2, right? And we have to consider it could be a negative 1 or it could be a positive 1. You're not going to consider the 3 right now. It will make it does affect things, definitely. But when trying to find that first factor, we're just going to look at that last term and say it could be plus or minus 1 or plus or minus 2. So what I'm going to do is I'm going to say this whole thing again. I'm going to let p of x equal this whole thing. So I'm going to check. I'm going to check what happens if I plug in 1. Do I get a remainder of 0? We're just trying to find that key first factor. So if I plug in 1, I'm going to get 3 minus 4 minus 5 plus 2. Oh, disappointment. We got a remainder of negative 4. So I have to try another one. Worst case scenario is you get unlucky and choose all the wrong ones first before you finally choose the right one. Personally, I like choosing 1 and negative 1 first because with the remainder theorem, those ones provide the easiest mental math. So now if I plug in negative 1, negative 1 cubed will be negative 1 times 3 is negative 3, minus 4, plus 5, plus 2. Yes. And as soon as you get a remainder of 0, right beside it, a minus 1 there means that x plus 1 is a factor. We change signs so often in this that that's one of the parts that people get confused on. Sometimes they overchange signs, sometimes they don't change signs, so be careful with that. So once you find one factor, okay, then you can use synthetic division. So we're going to set up our synthetic division, and we're going to say we'd put a minus 1 out here. Our polynomial was in order already, nothing missing. 3, negative 4, negative 5, 2. Bring down the 3. Multiply and add. Multiply and add. Sure enough, we get a remainder of 0 again. What happened to the negative 4? Right here in this one? Like in this box right here? In the p negative 1. Why is this a negative? So if we look at plugging in negative 1 in here, order of operations would say negative 1 gets squared, and negative 1 times negative 1 is positive 1. And then that positive 1 gets multiplied by the minus 4, giving us a minus 4. So that's why this is a negative 4 right there. So once we find one factor, we can use synthetic division, and the reason we use synthetic division is so that we can write our division statement. And since I've defined p of x as my original function, I can say my polynomial, which is the 3x cubed minus 4x squared minus 5x plus 2, but it sure is a lot quicker to write p of x, equals, we found out that x plus 1 is a factor, and that's what we used in our synthetic division, and our quotient is 3x squared minus 7x plus 2. And because the thing that we got is a quadratic, and you already know how to factor quadratics, we can just finish factoring completely by factoring 3x squared minus 7x plus 2. Yes?
Is it okay to just write p of x now instead of actually?
If you define, so you have to say let p of x equal, if you define it at the beginning, that's fine. And that sure makes all of your work look nicer all the way through. But you do have to define that so that you can write it. And when you're factoring it, you do need to make a statement that says my original function equals. And so now factoring this last part, 3x squared, this has to be 3x and x because those are my first ones. My last one's a 2. So I know this has to be 1 and 2 or 2 and 1. I'm going to put the 2 here so my outside is 6 and the 1 here so my inside is 1 because that makes 7. In order to get a negative 7, I need a negative 6 and a negative 1 to do that. And now we have factored completely. So on these questions that say factor completely, let's just summarize what we did. Number 1. First thing we had to do was find a factor. Well, how did we do that? We looked at our constant term. And then we used our remainder theorem till we found a remainder of 0. After we did that, we used synthetic division with our factor. And we wrote the division statement. So once we found out our factor was x plus 1, here we use synthetic division, and we wrote our division statement. Go down this way more? Go up. So we found a factor, then use synthetic division, and write the division statement. And finally, if you get a quadratic, factor that quadratic, or sometimes you're going to start with an x to the 4. Then you would get an x cubed, which you can't factor. In which case you'd have to repeat steps 1, we'll repeat steps 1 and 2 again until you get to a quadratic equation which you can factor. So we will do some that start with an x to the 4. You find a factor, use synthetic division, you get an x to the 3. Then you have to do that with that x to the 3, repeat this process again. So we'll do some practice with these later this morning as well. Okay, when doing your practice for these ones, this is the order that I want you to do them in. Start with number 5, then do number 11, then number 9, and finally 10b.